little a discourse about, let's just use like placeholder function foo that does nothing, like this, and do a little bit of a demonstration here. So I create integer variable x and initialize it with some value 1, 2, 3. Okay, so now I have a variable named x. If you think about its location in memory, apparently there is some kind of integer variable in memory like this that looks like a box, and it has a name like x, right? So, and this is where the actual value 1, 2, 3 is stored inside this box, right, in computer memory. And what is x? X is a named integer, right? X is an integer. It contains the value, whichever we would like, and x provide its direct instant name. So it's a named location in memory. But if I do this, now this variable x has two names, x and y. Okay, so y is the second name of this variable, integer variable stored in memory, and originally it was given a name x, and now it has a second name y. So this second name is a complete synonym. Am I spelling this right? Synonym, we'll say second name of x. Second name of x. Okay, so x has two names now, which now means that if I say x equals 5, or if I say y equals 5, these are two exactly the same statements. They do the same thing. They change the value here to 5. Okay, so basically you can add additional names to existing objects. Why is this helpful? Well, to use it, uniformly or independently like this is probably not a very popular idea. Why would you confuse yourself by adding two names to the same integer? It's probably an unlikely thing to do. Well, perhaps, maybe if I have something complicated like say for instance that I have a vector of some structures, like I have a vector that uses an index, and here I make a computation by using some function call which takes many different parameters like this, and basically to type something like this multiple times becomes a difficulty. Then I can say, create a reference I can create a reference to this location like this, and perhaps then instead of using this, I can shorten it to something like this. But it's still not a very typical use of this facility, like second name or synonym. Right, so I just get rid of this for now. But this is where the reference becomes very helpful. Right? Let's create function name bar. And it's taking integer y as a parameter. And what this function bar does, it simply increments y. Okay, very simple function. Function that takes an integer and increments it. Now remember, function parameters are just local variables inside the function. They don't have visibility outside the function, and basically if I start calling it, let's temporarily do this, right? Say bar and pass x as a parameter. What happens here on this line is that the value 123, which is stored inside this this memory, right, is copied somewhere else. Let's just temporarily forget about this portion, right? That as if we never had this code. Don't even make it visible. I don't want to get rid of it, but keep it invisible right now, right? So what happens is that somewhere in memory, this function bar will get its own copy of integer x, okay? And as part of the call, right? This is like during the call, as part of this call, as we're attempting to call this function, what happens is that the value is copied. So this variable is a copy of this original variable. But using these tricks that x can have more than one name in the programming language that we're using, if I modify this parameter type to be a reference, by the way, the ampersand sign in declaration of the variable makes it, instead of being an independent integer, makes it a reference or synonym. So instead of this time, if I have this function that uses function parameter as a reference to another variable or second name to another variable, so we're no longer making a copy, right? Instead, what we're doing, just like before, we simply, without making any copy, we give function bar something that's called a y, but it's the second name of the original variable x, which is located inside function foo. Okay, so therefore, if I say bar and use a reference to another object and say plus plus over here, upon return, this x will be incremented, and therefore, upon return, x becomes 124 because it's incremented, right? So in situation like we started, right? So I now bring back this view where we got started. Creating standalone reference to existing variables is not very productive or needed. Like it's even confusing to why should my integer x have two names, x and y, but as a function parameter, if it becomes, instead of independent variable, if it becomes a reference to an existing object, it becomes very, very useful, because now, although I call another function, inside this other function, I am manipulating not brand new variable, but the original variable x. And so references become extremely valuable in this sense, right? So no, if we use this, remember this sign right here, which is the syntactically, we say that y is a reference to another, let's just say to an integer, right? This is what y is. Y is not an integer. It becomes this ampersand right here modifies y to become a reference to another integer existing somewhere else and not an independent standalone integer. Therefore, of course, when we call bar, we must provide uh, the name of existing object which is x, which is an int, and then here if we continue using this y, which is a reference, it will be modifying object that exists in a different scope, in scope of different function. So this is how useful references can be. And look, in my example, now let's roll back to our situation. We have this recording that we want to be able to share with other parts of the program. What parts of the program? Other functions. So yes, of course, we can create a vector and we can pass it as a parameter to other functions, but how about we, instead of passing recording by copying it, by like taking copy of the original recording and making a copy of it. Instead, we say do not make any copies, just take this vector by reference. And therefore, right here, if I say recording push back, I am modifying this vector that I created inside main function, right? So the main function declared vector object, and it got created over here. But now if I pass this by parameter, like using parameter syntax, to another part of my program, here it does not become a separate object. It refers to the original one. And all that needs to be done is just simply using an ampersand. So let's test this, but before we test this, I know already that I need to jump back to the header file and make sure that I update function declarations with this ampersand. So we save everything, right? So these are the changes so far. By the way, no changes in main. The same thing. The same vector recording, the same passing of the parameters, but now if the function is taking recording by reference, as you can see with my ampersand over here, the trick should work. So I save it, quickly build. Somewhere, or yes, this illustration has to be a comment and not the real code. Okay, so I separate it as a comment, build this and something else. Let me just stop it.